Hello and welcome to Class Time.
I am Karima Mundell Thomas.
And I am Latoya Shiraya. We'll be guiding you through today's mathematics lesson. Let's begin.
Let's begin.
So what are we doing today, Karima?
Well, we're looking at answering multiple choice questions.
Okay.
And in particular, we're going to be zooming in on questions related to algebra, relations, functions, and graphs.
All right, sounds good.
Right, but before we get into the meat of the matter, we want to at least give our students some strategies that they can use when answering multiple choice questions.
Fair enough.
All right. So one of the things we want to encourage our students to do is to read each question carefully. And when we talk about the question, we're not talking about just the stem, but the options as well. I don't know if it has ever happened to you, Latoya. You've read a question and immediately you started working. And then when you look at the options, you were like, oh my goodness, I didn't need to
do all of that.
Exactly.
Right.
So read the entire question carefully.
All right, got it.
Find keywords or phrases in the question that will help you to choose the correct answer.
All right, especially that not. You want to look out for the not.
Yeah, definitely. All right, so another strategy is to work the easiest problems first. So we know the exam is timed, right?
Yes.
And so we want to ensure that, we try as much as possible to answer those questions that require maybe less effort.
Yes.
Yes, before we get to the more difficult questions.
Because we know that there are 60 questions and you have 1.5 minutes.
Hour?
No, to answer each question.
Oh, okay.
So the exam is 1.5 hour and you have 1.5 minutes to answer each question. That's not a lot of time.
No, it isn't. And there are some questions that may actually require a little more than that.
Right.
So you want to answer the easier questions in a shorter time so that you make up for the harder questions that you'll need more time to complete.
Agreed.
So that takes us into the next thing. Pace yourself, right? Don't spend too much time on any one question,
yes,
right? Attempt the question, do your best, and then move to another question.
Watch the clock.
Definitely. We also encourage our students to estimate the answers. And what we mean by that, when you read a question, think about what the question is asking and develop in your mind an idea of what the correct answer may look like.
So is it a large number? Is it a small number? Is it something with a variable?
And you could actually even break it down a little bit more detailed than that in your estimate.
Right.
But having estimated the answers, what that does for you is that it helps you to eliminate any wrong answer. So that transitions us into the next point. Eliminate any wrong answers, right? And I want to point out that the estimating, you're not using your estimate to necessarily select the correct answer, but you're using it to eliminate any answers that you are sure would not be correct.
Makes sense.
All right. So one of the things we want to highlight, Latoya, if you eliminate 2 incorrect answers, your chances of choosing the right answer is greater. True.
Right, because if I have 4 questions, it means that I have 4 options. Sorry, it means that I have 25% chance of getting a correct answer. But if I definitely eliminate 2, now I have a 50% chance of getting the correct answer. Yes.
There you go. Another thing we want to encourage our students to do is to work backwards. What do we mean? When you get an answer, plug back that answer into the question and see if it actually works out. All right, so we're encouraging that. And there are sometimes too, maybe you're not so sure, we're hoping to build your confidence today, but just in case you're not so sure, there may be questions that you actually have to try the options and see which one actually gives the correct answer.
As you said. All right.
No, a lot of times students tend to, change their answers multiple times. One of the things we want to encourage is that you don't change your answer unless you're sure of the correction.
Okay.
Ensure that the reason you're changing your answer is legit. That's what we're saying.
Makes sense.
Yeah.
And not because your neighbor has that answer.
We're not even going there, okay? Now, if your answer does not match one of the choices, because we know it's multiple choice, and for this particular multiple choice, it's single response, of course, and there are 4 options. So say, for example, you have answered the question and your answer does not match any of the responses. Reread the problem, recopy the numbers, and try solving again.
Because 9 times out of 10, the correct answer is there.
Okay. And finally, we want to encourage our students to not leave any question unanswered, right? Don't leave any question unanswered. Answer all questions. There is no penalty for answering incorrectly, right? And you mentioned something about, chance. So if I don't answer a question, what are the chances of me getting it correct?
0.
0, right? But if I answer the question,
you have a 25% chance of getting the correct answer.
Better a 25% chance than 0 chance.
Share that letter and give yourself a chance.
No question should be left unanswered. All right. So
they got this.
Yeah, I believe so too. So we are looking at algebra in our first segment, and we're going to be taking you through a few questions. So let's start with question 1. If 3n is an even number, which of the following is an odd number?
Okay. All right. Okay.
You've got this.
All right. So if 3n, I'm reading the question, is an even number. See, I'm using my strategy there. If 3n is an even number, which of the following is an odd number? I have 3n minus 1, subtract 1, 3n subtract 2, 3n plus 2, 3n plus 2n. Okay, so what I'm going to do, I'm going to start with an even number.
All right.
Because they say 3n is an even number, any even number. So I'm starting with 6 is my even number.
All right.
And what I'm going to do, I'm going to follow through with the options to see which of these options will result in an odd number. That is my strategy that I'm going to use. I'm going to work backwards.
All right, fine by me.
All right. So starting with the first option, 3n minus 1, which is my 6. Remember, 6 is my 3n. When I subtract 1, that's 5.
And is 5 an odd number?
Yes, it is. But I'm not going to stop there. I'm going to try all my options to see if there's a better option, so to speak. Or if
to verify.
Just to verify,
all
yes?
Right, no problem.
All right, so the next option is 3n subtract 2. Remember, my 3n is 6. When I subtract 2, that's going to give me 4. That's an even number. So definitely can't work.
All right.
All right, next one is 3n plus 2. My 3n is 6. 6 plus 2, that's 8. And that is resulting in an even number. So C is definitely out. And I know that when you multiply any number by 2, the result will be an even number.
Okay.
And since I would have tried an even number at C, I know that D would not work out either.
Yes, I will also know that if we sum 2 even numbers, the result is definitely another even number.
Definitely.
Definitely.
And so my answer has to be E, 3n subtract 1.
All right, Latoya seem to be on point today. Let's see if we can step it up a bit and transition into question number 2.
All right.
And see how we can handle this one. So it says, if 3 multiplied by x subtract 1, of course, that's in bracket here, and then we're to subtract 2 times x subtract 1, all in bracket there again, and the result is 7. And they're asking us, what is the value of that quantity that's in bracket? In other words, what's the value of x subtract 1? And we have some options here.
Okay.
Now, when I looked at this question, Latoya, what popped out at me personally is that the quantity that's inside the bracket here.
Yes.
So 3 is multiplying the same quantity that 2 here is multiplying. So I'm thinking that really and truly, I'm seeing like terms coming out right here. So I can quickly identify my like terms, which are here. So this term, 3, is multiplying the very same thing in the bracket here, and the very same
X
thing
subtract 1
is in the bracket there.
Ah.
Right. So
lots of times we think of like terms as one variable, or the variables are right beside each other and not a factor.
Right,
Like
so,
this.
Definitely.
That's
so I
good.
wanted our students to really see what's happening here, that
Yes.
there's actually a nice way that we could actually simplify this.
Yes.
So if I had 3 of a particular value and I subtract 2 of that same value,
You just have one other value.
I just have 1 of that value left, right?
Easy peasy.
So I basically only have 1 of the x subtract 1 here.
Huh.
And what do you know? That's equal to 7.
You know, I wouldn't have done it that way.
I figured many persons probably would not have seen that, but you know, we have to show various ways.
I like this way.
Yeah.
I would have just gone the route of
Expanding the brackets
and simplifying.
Well,
Yeah.
we could do that. We could. Let's try that approach and see if it really works.
Okay, so we would distribute 3 across what's inside of the bracket there, which is x subtract 1, and likewise distributing 2 to what's inside of the bracket x subtract 1, and simplify. When I simplify, I did get the same answer.
There you go.
Love
and you
that.
see, this would have probably taken us a little bit more time.
Yes.
So we want to try as much as
Definitely.
possible to, you know, maximize.
Yes,
our
you want
time.
the more efficient strategies
There you go.
for that limited time
Definitely.
without the use of a calculator. Can I just say that?
Yes,
All
that's
right.
important.
So here you are. Here's our third question. The graph of the inequality in the diagram above is defined by, and we need to define that graph above.
So let's
Interesting.
let us pause a little bit and look at this, you know, with a critical eye.
All right, critical glasses on.
Great. So I'm looking at this number line here, and I'm noticing that when I look at this circle right here and this circle right here, they look identical.
Yes, yes.
Right?
Yes.
So even though I'm not quite sure what they mean as yet, I can use the fact that they are identical to actually eliminate some options.
All right.
So I'm expecting, therefore, that the symbols will either both have an or equal to component or both wouldn't
Without.
have it, right?
Okay.
So I'm looking at option A, and I notice I'm seeing the sign here, the first one without the or equal to component, and the second one
With.
with. So
Which is not reflecting what our graph is reflecting. So we can
Exactly.
eliminate that one.
Exactly.
All
and
right,
and for the
agreed.
same reason, we could
B.
actually eliminate B
Okay,
as
so we
well.
have a 50-50% chance of getting the correct answer.
There you go, girl.
All right, like
right
that.
on the ball. So now we need to figure out now, clearly, we need to know now, what do these circles mean? Now, they are unshaded.
Right?
What does the unshaded, what does an unshaded circle mean in the diagram?
What does the unshaded circle mean in the diagram?
All right, so the unshaded circle actually is telling us that in this case, x cannot be equal to the value identified.
Okay.
Right? So in this case, what are the values that have been identified? We have
Negative
-2 and we have
positive
positive 3. So we're saying x cannot be equal to any of those values, but x can be greater than -2, right? And it would be less than 3.
Definitely.
All right? So which of these options are we going for?
C.
Definitely option C, which is telling us -2 is less than x, which is less than 3.
And I also want to point out, even if sometimes you have a little trouble with identifying what that symbol represents, whether greater than or less than, we certainly know that D could not be our answer because it has the or equal to component on it.
For this question?
Yes.
Yeah.
Yes.
So those are clues that we can look out for.
Yes.
All right, let's go to question 4. If x is an integer that satisfies the inequality 6 subtract 2x is less than or equal to 8, then we're being asked to find which of these options is correct as it relates to the value of x. So I'm looking at this, Latoya. It looks like an inequality that we can simplify a bit.
Yes.
So let's do that. So we could actually subtract 6 from both sides of our inequality, and we're left with negative 2x is less than or equal to positive 2. So now we need to divide both sides by negative 2. What will that give us? So Latoya, here's the thing now. I remember something about what happens when you divide an inequality by a negative number, but I can't quite remember it right now. But one thing I know though, based on what I have, so x is either greater than or equal to or less than or equal to, we're not sure yet.
Yes.
But negative 1 is here. And so I could actually look back at my options and see options that could be eliminated.
Ah.
Yes. So I'm thinking B and C could be eliminated because those are showing me positive 1 right off the bat.
Right.
So I now need to decide between A and D. So let's see if we can explore a little bit.
All right.
Let's explore a bit. So we have negative 3 is less than 2, right? Is that a correct statement, Latoya?
It is.
It is, because we're looking at the number line and we're really seeing that negative 3 is actually less than positive 2. But here's my question. I am going to now divide negative 3, the entire inequality, by negative 1. So I'm dividing the entire inequality by negative 1. So now I have positive 3, and I kept the symbol as it was. So it's saying positive 3 is less than negative 2.
But that's not possible.
Is that correct?
No, it's not.
No, it's not correct, because I'm looking at the number line right here and I'm seeing that 3 is actually greater than negative 2.
It is.
So one of the things we're seeing here is that if we divide our inequality by some negative quantity, then something happens with the sign. Yes? And I want to also put it out there that we could have multiplied by negative 1 as well.
Right.
And
we
would have,
give the same result.
would have seen the same result. So we're noticing here that we can't just keep the inequality symbol as is if we have divided through by some negative quantity. So let's transfer that knowledge here. So now we have x is greater than or equal to negative 1. And our answer is D. Let's move right along. Question 5. So if m asterisk n, sometimes you might hear it as star in some cases, is equal to the square root of m squared subtract n squared, notice it's all under the square root symbol, then 5 star 3 is equal to?
We don't know. But let's find out.
Let's find out. But you know, Latoya, these binary operations, they really are a version in my mind of substitution, because you know, an operation is taking place on these two values.
Yes.
And we can see the operation clearly here.
Yes.
So all we need to do is to figure out which value is m and which one is n and substitute.
Yes.
So in this case, our m would be 5 because it appeared first, so we're following the order. And our n would actually be 3.
But I want to stop you here, Karima. I've read the CSEC report and I see where 5 squared, I can tell you that somebody is going to write 10. And 3 squared, somebody is going to write 6.
I know, right? And then they're going to get 4 underneath that square root symbol, don't? And choose 2 as the answer?
Yes.
Students, ensure you don't make that mistake. All right? Please.
Because
if
you choose an incorrect answer, it might just be one of the options.
I know, right? Because there are 4 and only 1 is correct.
Because it's an option means that it's correct.
Definitely.
Okay?
So let's finish this one, Latoya. So we know 5 squared is 25, 3 squared, of course, is 9.
Yes.
And if we subtract these values, we are finding now the square root of 16.
Which is not 8.
Which is not 8.
But
4. All right, so let's go to question 6. And this is a follow-on from the previous one. But in this case, Latoya, we know that 3 asterisk 6 is actually 12, and 2 asterisk 5 is actually 9. And now we're being asked to find what is A asterisk B. What's defining that operation?
Okay, so that means that I'm looking at these two equations because they're equal signs there. And I need to see what pattern
all right
that I would have used to get these equations. So what would I have done to the 3 and the 6 to get 12? And I would have to do that very same thing to the 2 and the 5 to get 9.
I'm looking at it, I see a pattern coming out in my head, but I don't want to say it yet because I want us to actually look through the options for this one.
Just in case they can't pick it up.
Definitely. So let's run through these options quickly. So the first one says 4 multiplied B subtract A. So all we're doing here, Latoya, is to fill in the values for B and A and actually working it out. Now, having done the substitution here, we're seeing that the result of what's in the bracket is 3, and of course 4 multiplied 3 is 12.
Right,
so it's actually work for the first one.
But
can I select it for the answer?
No, because it has to work for both options.
Has to work for both options. So let's test it for the second one.
Well, we got 12, but that's not what we're supposed to get.
We're supposed to get 9, right?
We're supposed to get 9. So clearly this cannot be the rule,
Can't be
so
it.
to speak, for this one.
Let's try B. So here it's A squared subtract B squared. So here we substituted our values and
we're not getting that 12.
We're not getting that 12. Does it make sense to check the second one?
It doesn't, because remember we're working on a time constraint
and it must
we
work
ain't got
for both.
time to waste.
Yes.
All right, so definitely B is out.
Let's try C. All right, and we come up on one more, Latoya, that actually works.
Okay, but it works for one.
For one. Let's test if it works for the other.
Womp womp.
Or substitute. Oh, 7 and not 9. Ouch.
Womp womp. Okay, students, when you get to this point, you might be tempted to say, oh, it's D. Check it out. Okay? Work it first before you check. Just in case you made an error
somewhere up top, exactly.
Yes.
So let's check.
Substitute.
So here we have 2A added to B, and of course we're substituting our A as 3 and our B as 6. And what do you know? We got our 12. Let's check the other part. Works nicely.
It did.
It did. So our correct answer here is D.
All right.
Now, this question gave us some values for the variables x, y, and t. X is equal to -1, y is equal to 3, and t is equal to 2. And we're asked for the value of x divided by y, all raised to the power of t.
T'd.
All t'd.
Yes.
So this is a fairly simple question, so let's do our substitution. Now, I want to point out here, Latoya, that the entire fraction is squared.
Yes.
Right? And we know from before that when values are squared, whether they were positive or negative in the first place, really doesn't matter. The result is actually a positive value.
Right.
Yes, so in my mind, A is out in my head.
Oh.
Immediately.
Yes.
But yeah. So let's work it out though. We know that square means to multiply a number or quantity by itself, which we have done here. And so the result is 4/9. And I wanted to notice that option A was -4/9, not true?
Yes.
So it's important for us to understand what happens when we square values.
And I also want to point out, just in case you would have only squared the numerator, there's an option there for you, which is C.
So you have to be very careful and ensure that you realize that the entire fraction is squared.
Definitely.
Definitely. All right, question 8. This one is fairly simple. It's a fraction addition. Sometimes students get scared of fractions, not true?
Yes.
Especially algebraic fractions,
Definitely.
right? But they operate on the same principle, don't
It's
they?
the same.
Same
Yeah.
principle. So what do we need to do first?
Find the LCM.
But when we're looking at the LCM, Natalia, we know, this LCM could never be 8x squared at all, because 8, first of all, is not even a multiple of 5 and 3, right?
Neither of the two. So we can go ahead and eliminate
A and B for
right.
sure. But what's the LCM though?
Call yourself the bigger number. Okay, just
Really?
kidding. 15x.
So the LCM is actually 15x. Now, just as though we would actually work our algebra or regular fractions without
yes.
variables, it's the same idea. So let us now look what will our numerator be now that we have found our LCM. So we have rewritten the fractions using 15x as our denominator. Now we know that 5x into 15x is actually 3 times.
Yes.
We didn't just take the 3 and put up there, right?
Right, we created equivalent
we created
fractions.
equivalent fractions because our numerator must now be multiplied by 3.
Yes.
Similar approach, 3x, if we were to see how many times it goes into 15x, would have been 5 times, correct?
Yes.
Notice now, again, that we're creating equivalent fractions, and so it's 2 multiplied by 5 to give us 10. Now that we have the same denominator, Latoya, same principle applies again. We just operate on the numerator, so we add them.
Yes, ma'am.
Yes, ma'am. There we go. Beautiful.
Easy peasy cheesy. Wow. Algebra finish already?
Time flies when you're having fun, right?
Right.
So now we need to transition into relations, functions, and graphs.
All right. Don't take off your algebra hat. There is some algebra here.
Definitely.
Yes. So the equation of the line passing through the point 0, 2 and has a gradient of 1/3 is, so what are we required to do? We need to find the equation of the line.
Yes, and there's something, we have a general equation that we use for straight lines, right?
Yes, we do.
What's that again?
Y equal mx plus c.
Right, so y equal mx plus c. But m and c are actually values, yeah?
Very
Constants.
special values that we know.
What does the m represent again?
I think it's the gradient.
Gradient, right. So hold on, pause. So I'm looking at the question, right? And it tells me that I'm looking for the equation of a line whose gradient is 1/3.
Right.
I know that the m value represents the gradient.
Yes.
So where m is, I'm expecting to see 1/3.
Yes.
So let's look at our options now.
Okay.
So we have
can
y
eliminate.
equal 3x, clearly.
Not it.
Not 8. Y equal 3x added to 2. Again, not 8. So we're increasing our chances, right?
Yes, 50-50.
All right, but there are 2 of them there that has m being 1/3 or the gradient being 1/3. So we need a little bit more information.
Yes. But we know that the c value represents the y-intercept.
That's a big word.
I'm going to tell you, ma'am.
Okay.
What happens at the y-intercept? Well, this is where the this is the y-coordinate when x equals 0. The point where the curve cuts the y-axis.
Curve, remember this is a
line. The line cuts the y-axis.
All right, so I'm looking at this, Latoya, and it says that the y-intercept is that y-coordinate when x is equal to 0. So let's double back to our point in the question. So we're looking at this point right here. What's the x value there?
0.
Okay, what's the y value there?
2.
2. Therefore, when I look at my equation, right where c is supposed to be, I should see a value of positive 2.
Yes.
So let's look now. And from there, we can clearly select our correct answer.
Which is D.
There you go.
Okay, that was pretty easy.
Yeah, not bad.
Not
let's
bad
continue.
at all. All right, so what is the gradient of the straight line 2y equal negative 3x subtract 8? Okay, so they give us the equation and we need to find the gradient.
Yeah.
But I can pick it out easy, man. You just tell me that the m is the gradient and it's right there, -3.
If you dare say -3, you know, I should just send you a virtual conch right now. Remember the general equation is y equal mx plus c.
Oh.
This is not saying y equals something. It is saying 2y is equal to -3x subtract 8.
Okay, my bad.
Yes, so please kindly get this equation in the general form and then we can talk. So let's go.
All right, so students, don't be like me. Don't make that error, okay?
Please don't. So we can easily divide through, right, by +2. And that now tells me that the equation is actually y equal -3/2 x subtract 4.
Okay, so now I know my gradient.
Yes.
That's -3/2.
Yes.
But guess what? As we said earlier, I chose -3 as my answer and there was -3 in the option.
So we have to be very careful and we have to be on point and as accurate as possible.
Yes, ma'am.
Definitely.
All right.
And we seem to be on a linear path this morning. Yes.
Which of the following points lie on the line y equal 2x subtract 3?
All right. So, Latoya, to figure out if the points lie on the line, we really need to figure out if these x values, when we actually put them in the function here,
yes,
if the y values are matching up.
That makes sense.
So let's use a table for this.
Okay.
So we're going to start with the first point. So we're using the option of checking the possible answers and seeing which one works. Working backwards.
All right.
So let's go with 2.
So when I put 2 in the equation,
here, so
substituting for x
multiplied by 2 would have given us 4.
Yes.
Subtract 3 would give us 1.
Which means that's not A.
Not A.
All right.
Let's try B. All right, so we have our 4 there. 2 multiplied by 4 gives us 8. Subtract 3 gives us 5.
And that's not...
B is out as well. Let's run along with 0. So 2 multiplied by 0 is 0. Subtract 3.
That's -3. So that works. But we're not going to just choose that. We're
in case I made a mistake, right?
Yes.
All right, let's check -2. So 2 multiplied by -2 is actually -4.
Yes.
Subtract 3 is actually -7.
And somebody might say -4 subtract 3 is going to give them -1.
You know, right? And that's why that option is there.
Yes.
Again, be very careful.
Precise.
Very, very careful.
Precision is very important. So our answer is indeed C.
And I want to point out, Latoya, because earlier we said the C value, let's look at our C value here. Our C value here is actually -3.
Yes.
And we said that is the value that corresponds with
when x equals 0.
So again, we can double check.
And if you knew that, then quickly you wouldn't necessarily need to go through because you have a premise, a very conceptual premise on which you can choose your answer, saving you on some time.
There you go.
All
Definitely.
right.
Let's move on.
So the range of f...
All right, so f basically is mapping x here to -x squared. All right, so we have a function such that our x values are mapping to -x squared. And we're asked for the range, and we've been given the domain. And we have the list of values there, -2, -1, 0, 1, 2.
Fancy words, range and domain.
I was just about to ask you, what's the range, what's the domain?
What's the domain? Okay, so what I can recall, the domain are your x values, your input values.
All right.
And the range are usually your y values, your output values.
All right, so let's do some inputting. And is that a word? Anyway, let's do that and check.
So we're going to input the domain into the function, which is -x squared, yes?
Yes.
And we need to see what will be the output values to determine the range. All right?
So let's check. So -2, we know that when we square -2, it's positive 4, right?
Yes.
But guess what? We have to be careful of this negative right here because it means every value I get when I square x, I need to multiply it by negative 1. So if I got 4 when I squared negative 2, I need to multiply it by negative 1, which is going to now give me negative 4.
Okay. Got you.
Similarly, if I square negative 1, it's going to be positive 1, but I need to multiply by negative 1 here.
So it's not that you're saying negative x squared.
So it's not negative x all squared.
Right.
The square here is applying only to the x.
And
so
then
once
you
you get the
find the
answer,
negative.
we have to multiply by negative 1.
Got you.
All right, so let's fill in. So notice now, when I start to input those positive values, again, when I square 1, it's still positive 1. Same thing as when I square negative 1. But again, when I multiply by this negative 1 here as a coefficient, then it's actually going to map me right back to negative 1.
And likewise for positive 2.
There you go. So we're seeing here that the range is actually, let's check, negative 4, negative 1, and 0. B. Great.
Okay. Right. Which of the following represents the graph of a function? What is a function?
So here's the thing. What I remember about function, in a nutshell, just in case you don't remember the fancy definition, you want to ensure that each input value maps to only one output. In other words, you want to make sure that each x match to only one y.
Okay.
Now, when it's in a graph like this, we can do what's called a vertical line test.
Okay.
So,
What's that?
well, as the name suggests, it's checking it with a vertical line. So,
Okay.
you have a pencil in the exam now.
Okay.
So, I'm going to reach for a pencil and see what's happening. So, we're going to pass this pencil across the graph. I hope our students saw that. Let's do it again, Latoya. And we're checking if it's passing any 2 points at the same time, any 2 of these. So do it again, Latoya. All right, only pass 1 here, 1 there, 1 there, 1 there.
Okay.
So this seems to have passed the vertical line test.
Okay.
But for the benefit of our students, we're going to check the others
Definitely.
and see what's happening. Right
2
there.
there.
2
2
there
there.
again. So we
Okay.
notice here, do it again. So we're noticing here, Latoya, that right at this point, there is a single x value here matching to
2 y values.
2 different y values.
Yes.
So as we're passing the pencil across, we'll notice that it will pass these 2 points at the same time. And we see the same thing happening out here. Failed the vertical line test.
0.
Let's check C.
I didn't even have to check C though. All of them are
Right.
on a vertical line.
That was a giveaway, right?
Yes.
All right, let's check D. Right there. See that?
Yes.
Yes, so this 1x value here is mapping to 3
3 y values.
y values.
Which means then that
A would be the only one that's really showing us a function. Not true. The others
Yes.
may be relations, but
Not a
certainly not
function.
functions.
and that's what they asked for.
Definitely. So let's run along. Question 14. Which of the following diagrams best illustrates a function? So we're on the streak of a function again.
You know, I was about to choose my option.
You
and
were?
Then I realized that the arrows are pointing into the opposite direction of what I'm used to. Because usually the first oval with values or circles at this moment would represent your input values mapping to your output values. However, this time it's the output.
That is shown first.
Yes. Yes.
I noticed that too. When I saw this question, I was like, somebody trying to,
Trick us.
or see if you really know
We really
If
know.
you really know, that's the thing. So let's examine them. So we're seeing here our input values are here and our output values are here. Don't be fooled, students, if you see something like this. All right, so let's check. We said each input value must match to only one output value. So let's check. Input, yeah, 1. This input, mapping to only
2.
It's mapping to 2.
Yes.
So,
X beside.
So it missed the mark, not true? Missed the mark, definitely. So let's check this one. Yes, mapping to 1, but problem right here. This one is matching to 2 separate ones. Let's check here. Well, that not mapping to anything. Here, problem. Let's check this one. Mapping to 1. Here it's input mapping to 1. And here input mapping to 1.
Ding, ding, ding. We have a winner.
Ding, ding. We have a winner.
So you want to pay attention to the direction of the arrow, which will tell you where is your input values and where are the output values.
Definitely.
And that will help you to decide which of the diagram is representing a function. Be not fooled. It doesn't have to be on the left. It doesn't have to be on the right.
Just watch the arrows, yeah?
Just watch
and
the
get
arrows.
the direction. All right. So question 15 asks us about the gradient. We're going to read the question. The gradient of AB in the figure is...
Okay, so this time we didn't get a equation, but we got a
diagram.
A graph.
A graph.
Okay.
So I'm looking at this, Latoya, and reading my graph from left to right? I'm seeing that I'm pretty much going up a slope.
Positivity.
Going up a slope. So I'm expecting my gradient to be positive, right?
Yes.
All right. So we could actually eliminate some options here. We can eliminate 2, and we can eliminate, we can eliminate -2 and -1/2. We're going to allow our students to munch on this.
Yeah, ooh, like that.
We're going to allow our students to munch on this. So, Latoya, we were just looking at this question, right?
Yes.
And we noticed that as we were moving from left to right, when we examined our graph, we were seeing that it was going in an upward direction.
Positive.
And so we said that the gradient must be positive.
Yes.
And so by virtue of that, we eliminated option C, which is -1/2.
Yes.
And option D, which is -2, right?
Okay.
So we need to decide now between +2 and +1/2. Let's see.
How do we
find gradients?
Yeah.
All right,
from a graph, that is, because we know it's the M in the equation.
So I need to see what's the vertical movement. So let's check that first. All right, so there's my vertical movement, and that's 2 units. Let's check my horizontal movement, 4 units.
Okay.
All right, so it's my vertical movement divided by my horizontal movement.
You might hear a change in
Y divided by change in X. All right, so let's fill in the values that we obtained here. And that can be simplified to 1/2.
All
Great.
right.
Awesome. Awesome. Question number 16. Now,
16 already?
already. So if A, B, and C, right, are constants, and in this case, we know that A is greater than 0 for this question. The equation of the graph could be which of these?
Okay.
So looking at them clearly, they're all quadratic, so no giveaways there. However, what do we notice about this curve?
It's smiling. Happy.
It's happy, right? It's happy. So as we look at this type of curve where we have a minimum value down here, then we say that the graph smiles in layman terms. But what that tells us is that my A value is actually a negative value, right? Which means that when I'm looking at these equations here, let's look at A. A says y equal ax squared. A already
Negative or positive?
Positive, what did I say?
Negative.
Oh my goodness.
Positive. That's okay.
Okay, thank you so much.
And it says it in the question that A is greater than 0.
Right. Thank you for picking me up, Latoya. I tell you,
problem.
when you're tired, you see. Now, let's examine the equations here. So we're looking for A being some positive value. So we're eliminating anywhere that we see A showing up as negative.
Yes.
Right? Which would be B here, because we have negative A here. And let's check this one. Aha. So we can eliminate those.
So we're looking at the x squared term.
So graphs for equations like B and D would be frowning. All right.
Sad.
So we're choosing now between A and C. Now, one of the things I know, Latoya, is that the C value, and I want our students to zoom in, our C value, if we started with a graph right here, our C value basically just moves it up or down. It never shifts it in any other direction, right?
Okay.
Another thing I know is that my B value, whenever B is 0, right, my line of symmetry is my y-axis. So in other words, if B is 0, my graph must be somewhere here so that the y-axis is my line of symmetry.
Okay.
So when I look at this graph, Latoya, I'm seeing the line of symmetry coming in, and it certainly does not look like
the y-axis.
The y-axis. So what the B value does is that it shifts the graph, right? It shifts the graph in such a way that the y-axis is no longer the axis of symmetry.
Okay, which
right?
suggests that we have a B value.
Which suggests,
greater
based
than
on this,
0.
that we
Or
have a B value that's not 0.
That's not 0.
We have a B value that's
Yes.
not 0. So let's look back at our options now and see. Option A, once we're not seeing any BX here, it means that B is 0.
Yes.
Could not be the option. So we can actually select C.
All right.
Beautiful. So, our final question. If f of x is equal to 3x added to 2, and g of x is equal to 2x added to 5, we're asked to find the value of f of g of 5.
Okay.
What does this mean?
So we're doing composite functions, yes? So, okay, I can simplify g of x first.
All right, so we're going to find g of 5.
G
so in
of
other
5,
words, wherever
yes.
x is, I'm going to put
Substitute 5.
5 there. In which
Yes.
function?
The g of x function.
So let's do that quickly.
So g of 5 is now 15. 2 multiplied by 5, that's 10. Added 5, 15.
All right, so what am I going to do with this 15 now? I'm confused.
Okay, so I know that g of 5 is 15. So I was originally asked to find f of g of 5. I know that's 15, so I'm now finding f of 15.
Oh, so I'm realizing, Latoya, that whatever g of 5 was, in
Yes.
our case it's 15,
Substituting.
we need to substitute it into
The
the f of x function. Okay,
Yes.
beautiful. So let's do that. All right, so f of x is 3x added to 2, and so we can easily now substitute our 15.
That's
47.
which is D.
What do you know?
I like that. I like that.
Yes.
So I saw this very nice picture, Karima, and I had to show the students. You don't want to be like Sylvester here, right? You're going to come prepared, okay? And you're going to just read the questions carefully twice, thrice if you must. Pace yourself, guys. Estimate the answers if you can and eliminate the wrong answers. And do not leave any questions blank. Please.
Definitely. So guys, we're out of time for this lesson, right? Thank you so much for joining us today. Keep practicing and
Stay safe.
Yes, stay safe.
Wash your hand.
Sanitize.
Wear your mask.
Definitely.